All right, welcome outside to Powerwave Technologies. Here we have our active antenna demonstration, a live demonstration right now. As you can see at the top of our building, which is around 60 to 65 feet, we have a 4G MIMO active antenna array running at 2.6 gigahertz. This is a live system. It's deploying our most advanced RF technology, integrating our antennas and radio head. We call it our ultra-broadband radio antenna. And we are now allowed to transmit up to 2 watts of power by FCC, and we're going to demonstrate to you a very high quality signal coming out of this active antenna that is running at least around 500 to 600 feet and getting very high modulation, very high performance capability. As you can see, the active antenna is actually replacing a physical macro cell site tower with a very slim design, very integrated box, one box solution that has coming out of it power supply and CPRI or fiber interface to a baseband module. This solution is actually a full replacement for a base station and can support up to 100 megabits of throughput and very broadband capability. That's why we call it the ultra broadband radio antenna. So this is an active demonstration of our ultra broadband radio antenna. As we talked earlier, we've got the ultra broadband radio antenna located on the top of our building around 60-65 feet. It's transmitting at 2.6 gigahertz license frequency. We got a license from the FCC to transmit up to 2 watts. Here we're showing a demonstration of that 20 megahertz LT signal being transmitted from the active antenna array. And as you can see, we're getting a very high modulation, 64 QAM modulation, which is very high spectral efficiency in terms of throughput and very low error vector magnitude, which is very critical for an LT OFDM based signal. And what that orchestrates into is either we can double the coverage of our system, or at the same locations we were getting say 16 QAM, we're getting 64 QAM. We believe we're getting a 2x advantage in throughput and capacity using this air interface technology and solution. So we're very excited about it. We're going to continue to do more testing, but this really demonstrates the capability of a very small integrated package and integrated footprint that gives you very high capacity still and gives you macro-like capacity with a very small footprint. Welcome. We're at the Wall of Fame at Powerwave Santa Ana, Orange County corporate headquarters, and here you have most of Powerwave's patent portfolio on the wall here. We have around 707 issued patents, worldwide patents that go from circuit technology all the way to full-scale wireless system technologies. We have 400 pending filings, so hopefully our plan is to make this wall all the way complete with patent portfolio. As you walk through it, you can see the history of Powerwave as well as part of this patent portfolio, all the way from our origins of power amplifier technology with the most efficient multi-carrier technology in the industry to now having the most advanced Pico base station and active array antenna technologies that allow you to incorporate all of these different subsystem components into one complete solution. We're very proud of this, and our engineers walk it every morning and feel proud to be part of Powerwave. Welcome to the Powerwave Santa Ana, Orange County antenna chamber. This is our state-of-the-art near-field spherical antenna chamber that allows you to test antenna and radio technologies all the way from the low megahertz, 100 megahertz, all the way to the high millimeter frequencies up to 30 to 40 gigahertz of frequency. We have 3 state-of-the-art chambers at Powerwave. Besides this one, there's one in Kista, Sweden, that is a far-field chamber that allows us to do a lot of testing for large ranges. We also have a new chamber in India, in Hyderabad, where we're doing testing for more of the government and military applications of lower spectrum, as well as looking at public safety. And here in Santa Ana, as you can walk in here with me, we have a pretty state-of-the-art chamber. It has very high accuracy and capability within the plus minus 0.1 dB accuracy range. As you can see, with multiple horns, we're allowed to illuminate inside the chamber with different test environment, test scenarios. Here's an antenna being tested right now. We take hundreds of thousands of measurements a day. It's all remotely accessible. It's very state-of-the-art. Gives us very high quality and reliability, shortens our design cycle, as well as improves our overall system performance. We're going to talk about our distributed antenna systems and Wi-Fi technology in one box solution. Here we have our high power Nexus FT product that allows you to integrate 2G, 3G, and 4G technology, and combining with our Wi-Fi access point, it allows an operator to have a full solution at a site like a stadium or an airport. Here we have our Nexus RT, which is medium power, a little lower power than this power, but it has the radio backhaul, so now you don't need a fiber interface. You can do a radio backhaul and repeater in one configuration. We have a live working unit right now of both of these systems, and here you can see, as an example, in the PCS spectrum, I can locate a CDMA signal at the lower end of the band, and I can put a WCDMA signal at the other end of the band. So basically, this is a solution for neutral host. I can mix and match 2G, 3G, and 4G technologies in one box and allow you to multiplex them all together. So at a site solution, you can have all the technologies be able to be re-amplified and get you the coverage and capacity you need. We've done the same thing for the medium low power. Here you can see a GSM signal, very narrow band, 200 kilo signal at one end of the spectrum, and then you can see another GSM signal at the other end of the spectrum. And that's the most worst case scenario when you have very low power and low narrow bandwidth combined with very high power. So it allows you to combine these technologies together and give you that effective capacity and coverage in a site solution. Powerwave has deployed these solutions extensively worldwide. We've got the largest deployment, as Ron mentioned earlier, in Makkah, in Saudi Arabia, where we deployed a full indoor-outdoor DAS system, millions of square meters solution out there. We're also deploying right now a large solution for subways in the United States and Latin America. We've built a couple of airport solutions as well and casinos, and we're expanding that business to different site solutions and configuration. But as you can see, we have both the high power and low power combination, so as an operator can optimize their network in different situations. The other advantage of these new products is that since they're forward compatible to advanced technologies, as LT and HSPA Plus be deployed, you not only get a coverage gain, as I showed on the chart, you also get a capacity gain because of adaptive modulation. You can now increase the capacity of the radio network. So as an example, in one of the solutions we've tested, if I put this Nexus RT solution in a site, you were traditionally getting 300 kilobits indoor because of the penetration losses and the multi-platform outdoor. If I use my Nexus RT solution, that 250 kilobits becomes 2.5 megabits. So that's a huge improvement for an indoor solution and gives you that 10x extra capacity and performance at a site.